Hello class, welcome to Geometry Lesson 9.3, Circles in the Coordinate Plane. So our essential question today is, how is the equation of a circle determined in the coordinate plane? Our goal is to use the equations and graphs of circles to solve problems. So let's go ahead and talk about some circle vocab. Now remember in the previous two lessons we talked about coordinate planes. As far as coordinate geometry is concerned, we talked about distance, midpoint, and so on. And we use this to prove various shapes, various quadrilaterals, triangles, etc., and theorems. Now we're going to focus exclusively on equations of circles. So a circle, remember, there's a geometric figure that is made of points that are all the same distance here from a given point. So they're all equidistant from some point. So for example, take this point on the circle. It's the same distance from the middle or the center of the circle as it is from this point is to the center. So they're all the same distance, and that's what makes it a circle. Now the center is essentially that middle part of the circle where it's the same distance from each point. So each point is a certain distance from a certain point, which we call the center, and this line that I just drew in red and in blue is known as the radius. It's the line segment from the center of the circle to a point or any point on the circle. And the diameter is the line segment with endpoints on the circle and that passes through the center. So this red radius that I drew, if I extend it on the other side where I have 2 points, one on each end of the circle, and then I draw a line segment that crosses through the center, I'll call that point C, capital C, then that entire red line segment that cuts through that center is a diameter. A chord is a line segment with both endpoints on the circle. So for example, a diameter is considered a chord, but these points can be at any 2 points on the circle, and the chord need not travel through the center of the circle. So for example, this right here would be a chord. And notice that it does not cross through the center of the circle. So it's any line segment with both endpoints on the circle. The diameter is known as the longest chord in a circle. And you can tell that here. This chord that I drew on the top is definitely shorter than this chord that cuts through the center. Now let's go ahead and derive the equation of a circle. So what if I told you that the equation of a circle actually comes from the Pythagorean theorem? Well, interestingly enough, because if you think of this as this r sort of like a hypotenuse, well then the coordinates here, you can think of it as x, y, and where this is a distance x and this is a distance y. And we know that the relationship between this x distance, the y distance, and this hypotenuse has to be that of a right triangle, such that x squared plus y squared equals r squared. Remember Pythagorean theorem, a squared plus b squared equals c squared. And this is essentially the way that you would define a circle, because no matter where you are in the circle, this point xy, for instance, this is still going to be the radius no matter what, and this is still going to be x and y. And so this is essentially how we derive the equation of a circle. So select a point on the circle, which we call xy. Draw the radius from the center hk to the selected point xy, this is in blue. Select the point xy on the circle, draw the radius from the center to the selected point. Use the distance formula to find the length of the radius of the circle. So we got here, let's say that this distance is x1, y1, and this distance here is x2, y2. Well, then the distance here is x2 minus x1. The distance here is y2 minus y1. And so this is the same thing as, and that's equal to the distance d, which is the same thing as r. This is equivalent to r. So r is equal to the square root of, in this case, the x2 and x1 is simply hk. We call that h and k. So I'm just going to replace that with h and k. It doesn't really matter which one's x1, if x1 is h or whatever, if x2 is h. But in this diagram, x1 is h, x and y1 is k. So we replace those, and we call x2, y2. We just simply call it xy. And so then we got the square root of the x minus h squared, y minus k squared is equal to r. And then remember, to get rid of that square root, we gotta we got to square both sides, and that's the only way that you can cancel out the square root. So the square root and the square cancel, leaving us with x minus h squared plus y minus k squared equals r squared. And this is the standard form of the equation of a circle. And this is related to the Pythagorean theorem. So now we got the equation of a circle, and this is known as the standard form. Now the general form of a circle looks somewhat like this, and is essentially the expanded form of this. So if I were to take this and expand it, remember to expand this, you would have to FOIL x minus h times x minus h, and you'd have to distribute. If you did all of this for y minus k and x minus h, you can combine them into a statement that looks like this, where you have you have an x squared term, a y squared term, and then you have some a term that has x, a term that has y, and then you have some kind of constant equaling 0. This is known as the general form of a circle. We will only deal with this form maybe 1 or 2 times. Most of the time we're interested in the standard form. So the general form of the equation of a circle is the expanded form of the standard form. For example, if the standard form is x minus 2 squared plus y plus 3 squared equals 25, well then if I were to FOIL the x minus 2 squared, x minus 2 times x minus 2, then I would get x squared, and then I would get minus 2x. So let me write this down, x squared minus 2x plus 4. Minus 2x and minus 2x is minus 4x. This should actually say minus 4x, not minus 2. And then if I were to expand this, y plus 3 times y plus 3, I would get y squared, y times y. 3 times y is 3y. Another 3 times y, which makes 6y, which we have here. And then finally 3 times 3, which is 9, which we get here. So it's essentially the expanded form of the standard form. And so this should say minus 4. And then what we do now is what we would like to do, and I forgot, what we would like to do is combine the 4 and the 9 together to get 13. And then we're going to essentially subtract 25 on both sides so that we can make that 0, because the general form has that to be 0. And then we got our C. We have our 2G, which is 6, and we have our 2F, which is negative 2. And then of course we have our x squared plus y squared. So you can see it follows the same format as this here. Okay, and that's how you convert something from a standard form to a general form. But we're going to be interested in converting from general form to standard form. That's the way that we want to do this, because we're more interested in the standard form. So to convert from general to standard, you need to use a process known as completing the square. So if I want to go this direction, which is what I said earlier, I want to go from general to standard, I need to use a process called CTS, completing the square. We'll talk about that in a second. All right, so example 1. Find the equation for the circle, known as circle A. That's a symbol for the circle right there. All right, so if I want to find the equation, first off, remember that the equation, the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared, the radius squared. HK are the coordinates of the center, so that's this center right here. So what are the coordinates of the center? It's -3 and -1. And that's going to be my HK. So we know H is -3, K is -1. Let's plug that in now. So H is -3, so minus -3 squared plus y minus K is -1, so -1. Now we know that 2 negatives make a positive, so this is x plus 3 squared plus y plus 1 squared equals r squared. We're almost done. We just got to find the radius. So we need to find the radius. And in order to do this, we want to find the radius from this point to this point indicated in the circle. Let me erase this for a second and just kind of move it to the side. So we want to find this distance here, and using another color, let's go ahead and get this distance. Now to get that distance, remember we're going to do the rise or run stuff. So we got to go up 1, 2, 3. So we got to go down 3 up 3 rather, from left to right, and then over 1. And so the distance of that, which is the radius, right, is the square root of 3 squared plus 1 squared. 3 times 3 is 9. 1 times 1 is 1. 9 plus 1 is 10. So we got the radius is the square root of 10. So we're going to plug that in for the radius there, giving us, we have x plus 3 squared, y plus 1 squared equals square root of 10 squared. And we know that the square and square root cancel, leaving us with 10. So our final answer for the equation of the circle A is x plus 3 squared plus y plus 1 squared equals 10. All right, example 2. Circle Q has radius 7 and is centered at the origin. Does the point -3 square root of 2, 5 lie on circle Q? Let's go ahead and get the equation of the circle. Because it has a radius of 7, we know r is 7. We know that it's centered at the origin, so hk is 0, 0. So we got h, we got k. So that's h and that's k. So we got our equation x. Let's rewrite the equation. So we got x minus 0, h is 0, origin, y minus 0, k is 0, origin, r is 7 squared. So the 0 doesn't really do anything, so that just leaves us with x squared. Again, similarly, the 0 doesn't do anything, we just got y squared, and then 7 squared is 49. So this is our equation of the circle, the standard form. Now let's see if this point lies on that circle. So this is going to be x, this is y. Let's use different colors for these. So let's call this x and this is y. So let's plug those in. -3 square root of 2 squared plus, now let's plug in for y, 5 squared. And that should be equal to 49. So this is a question mark right now. We don't know if that's true. We're going to find out. So we're going to do 3 squared. What's 3 squared? Or what's -3 squared? Well, -3 times -3 is 9. What's the square root of 2 squared? Well, remember, the square root of 2 squared, the square and the square root cancel, leaving us with just 2. So we have 9 times 2. And then we got 5 squared, which is 25. So we'll see if this is true. 9 times 2 is 18. So we got 18 plus 25 is equal to, question mark, 49. Well, 18 plus 25 is 43. And 43 does not equal to 49, which means that this point does not lie on the circle. So the point -3 square root of 2 and 5 doesn't lie on circle Q. And that is our answer. All right, so example 3, graph the following circle. So this time we're given the standard form of the equation of a circle, and we want to graph it. So remember, the standard form is x minus h squared plus y minus k squared equals r squared. So because r squared is 9, that means that r has to be 3, right? Because 3 squared is 9. So we take the square root of both sides and the principal square root, and you get r is 3. So we know that the radius of the circle is 3. And we also know that h matches up with the negative. If the negatives match up, that means h is positive. If the signs are different, like this, that means it's negative. So here, these match up, so h is positive. These do not match up, so k has to be negative. So it's going to be -4. Okay, so just remember that guideline. Same signs, positive, different signs, negative. So we know that the center of the circle is given by, using these coordinates here, it's given by 3, -4. Let's go ahead and trace that here. 1, 2, 3, 1, 2, 3, 4. So this is the center of the circle. I'll just call that C for the center. And a radius of 3. So that means from each point on that, from that center, we're going to go 3 units away. So we got 1, 2, 3. That's a point on the circle. 1, 2, 3, that's a point on the circle. 3, and then 1, 2, 3. And there you go. And those are 4 points on that circle. We can go ahead and draw the circle. It's not going to be a perfect circle because, you know, human error. I'm not very good at drawing this. So there is my circle. And this is circle. In this case, this is circle C because that's what I call the center C. So this is circle C. All right, so now for example 4, write the equation of the circle with the given radius and center. So we got the radius r is 5 square root of 5. So let's go ahead and do r squared. So we got to do this squared. So we got to do 5 squared is 25. And then remember, if I distribute this to this, the square and the square root cancel, leaving me with 5. So 25 times 5 is 125. So r squared is 125. And remember that this is hk. So the equation of a circle, remember, is x minus h squared plus y minus k squared equals r squared. So we got h is 2, so x minus 2 squared plus y minus negative 4 equals, we found r squared, it was 125. All right, the double negative here becomes positive, so I'm just going to change this to a positive 4, and that is my equation. Pretty straightforward. All right, so now we're going to convert each of the equations in general form to standard form. So this is what I mentioned earlier. We are generally interested in the standard form. So if we're given something in general form, we want to convert it to standard form. So how do we do this? Well, we got to do a process called CTS, complete the square. And I'll show you how this process works. Find the center and radius of each circle. Okay, so we're going to convert each of the equations first. Okay, so if you want to convert to standard form, remember that the standard form of the equation looks like x minus h squared plus y minus k squared equals r squared. So one of the first things you're going to want to do is move the constant over to the other side so that you get r squared there, okay? So you're going to move this 8 over to the other side, and in constants. So I'm going to subtract this over to the other side. And you also, at the same time, you're going to also want to combine, get the x terms together and get the y terms together. Because remember, the x terms tend to be together here, the y terms tend to be grouped up there. So you're going to want to kind of group the x terms together as well. So we're going to do that so that we're not wasting time. Leave yourself a little bit of room here. So that way you can group the x terms together and then group the y terms together with a little bit of room. And so 0 minus 8 is negative 8. Okay, so now we got the x terms together, we got the y terms together. Now we're going to actually complete the square. We got to convert this into something that is squared. So let's kind of show you how we would go about doing that. Let's pretend we have x minus 2 squared. Now if we do that, right, this is a perfect square, which is why we call it complete the square, because we want it to be a perfect square. Right now it's not a perfect square here, but this is a perfect square. So when I FOIL this, right, it's going to be x minus 2 times x minus 2. We got x squared minus 2x plus 4. 2 negatives is a positive if you multiply. And then you get, and this is what you got, right? This is a perfect square. So what we got to do is notice that we got 2 halves of the square, right? We got x, we got minus 2x, we got minus 2x. So this is cut in half. And this is the square of 2. So 2 squared gave us 4. So in order to get this to be a perfect square like this, we got to split this minus 8 into minus 4 and minus 4. So basically we got, this is going to be x squared, and then it's going to be minus 4x, and then minus 4x, right? And then this is going to be the square of the 2. And so this is going to be the square of the 4. What's 4 squared? Well, 4 squared is 16. Okay? So what we did is we split up this -8 into these two -4s, and then we added this third term, which was 16, right? And just because it's the square of 4. So this was the 4 squared. So let me just say I added that, okay? Now, if I add 4 squared here, then that means I got to add 4 squared to the other side. Whatever I do on one side, I got to do on the other side. Now, let's do the same thing here. Let's split the 2 into 1 and 1, just like this was normally -4x, right? This is x squared minus 4x plus 4. And then going here, you split into -2 and -2. So you got 2 is going to split into 1 and 1. Okay, so we got y squared plus 1y plus 1y. Okay, let's group these separately. And then what's 1 squared, right? We did 2 squared was 4, so 1 squared, the invisible 1 here, is going to be 1 squared is just 1, right? 1 times 1. So we added 1 squared here. Okay, so if we add 1 squared here, then we got to add 1 squared to the other side. Okay, and this is what we have so far. You try to, okay, so this is what we have. Oops. Okay, so let me go ahead and grab my pen. Okay, so this is what we have so far. Now we got 4 times 4 is 16, right? So this is equal to 16. This is equal to 1. So 16 plus 1 is 17. 17 minus 8 is 9. So we got 9 on the right-hand side. Now we got to convert this into a perfect square. Well, how do we do that? Well, use this pattern to help you. X squared minus 2x minus 2x plus 4 gave us, what did that give us? That gave us x minus 2 squared, right? So let's go back to that. Let me erase this for a second. So this underlined gave us x minus 2 squared. So the pattern is it's just x and then minus 2, right? Whatever, if this is negative, that's negative. So the pattern here is it's going to be x and then minus 4 squared. Now go ahead and try that out. X minus 4 times x minus 4. If I did that, I get x squared minus 4x minus 4x plus 16. That's exactly what I got here. So this checks out, okay? So we're just using the pattern of foiling and going backwards to help us out here. Okay, so this becomes x minus 4 squared plus, and then we got 1 and 1, so it's going to be y plus 1 squared equals 9. So we went ahead and completed the square. Now they're perfect squares. So let me go ahead and give you the guidelines here. The guideline here is if you want to complete the square, you got to get all the x's on one side. Okay, so let me do it off to the side here just to show you the shortcut now. So now that we know how to do it, let's show you the shortcut. We got x squared minus 8x, and then we got the y squared plus 2y. So what we did is we take this number and cut it in half, right? So 8 divided by 2 is 4. And then we square it, right? So we do 8 divided by 2 is 4, and then we square it, and that gives us 16. Same thing here, 2 divided by 2 is 1, and then 1 squared is 1. That's how you complete the square, and that's exactly what we did here. We got the same numbers. And then you take x minus and then half of that, and then y plus half of that. Okay, and that's the way that you could do it quickly without having to look at this pattern. Although this pattern, there's nothing wrong with it. All right, so we got our equation. And it's in standard form, so that's good, check. Now what is the center? Well, the center is HK, and the signs match, minus, minus, so that means H is equal to 4. The signs do not match here, minus and plus, which means K has to be -1. And the radius squared is 9, which means that the radius is 3, because 3 squared is 9. You take the square root of both sides. Okay, so that's our center and radius. Our center is 4, -1, with a radius equal to 3. This is the correct answer as well. All right, let's look at B, and this time we'll use the shortcut that I showed you. I'll kind of show you a little bit of both ways, but we'll focus more on the shortcut. So remember, add the 12 over to the other side, get the constants over to the other side. Group the x's together, group the y's together. All right, so now then you do the trick, right? So you take this and you cut it in half, minus 2x, and then you square it. So 4 divided by 2 is 2. 2 squared is 4. Okay, so 4 divided by 2, then you square it, and that gives you that number. And then you got to do that same thing here. So 6 divided by 2, and then square it, gives you that number. So that's going to be 6 divided by 2 is 3. 3 squared is 9. Okay, and that's how you complete the square. Now, because we added 4 here and we added 9, we got to do so on the other side. And there you go. So we completed the square technically. Now we got to go ahead and convert this to an actual square. So you do x minus, you take this middle number divided by 2 and square it, and that's it. And then this one, y, and then take this middle number, positive 6 divided by 2 is 3, and then square it. And that's converting it into a square. Now 9 plus 4 is 13, 13 plus 12 is 25. All right, so now we went ahead and converted it to standard form. Remember that the h is going to be 2, the k is going to be negative 3 because the signs are different, plus and minus, right? And then the radius squared is 25, which means that the square root of the radius squared is the radius, square root of 25 is 5. So the center is 2, negative 3 with a radius of 5. All right, that's going to do it for the video, guys. I hope you found this useful and hope you learned a few things. As usual, I'll see you in the next one.